Okay, so we're in the second day of chapter 2, section 5, and we're evaluating algebra expressions. We'll still use multiplication. This time, though, we have to do something before we can even multiply. We have to substitute. Okay, so this expression, a squared b, needs to be evaluated with the given fractions. Okay, so how do we plug those in? What are you going to do, Audrey?
5 over 6 to the second power times...
And you know what you need to do? That whole quantity is being raised to the second. So you need to put the whole thing in parentheses to show that. If you don't, it only looks like the top number, the numerator, is being squared. Okay? So make sure that the entire thing is being squared, which is something different. And then...
times negative 9 over 10.
Over 10. So our order of operation tells us, are we going to... what are we going to do first here? It tells us we do exponent. So this exponent is saying we have this entire expression happening twice. So make sure you expand it. The whole thing is happening twice. And then we can bring along this third fraction. And now we're back to yesterday. We have 3 fractions, we're multiplying. Who can tell us where we may reduce a little bit? Where do you see, Gabriel?
Well, you can do 5 times 5 is 25, and 6 times 6.
Well, we don't have a 5 left, do you see?
But instead of doing 5 over 6 times 5 over 6, can you do 25 over 36?
Well, you could, but we've already spent a little time reducing, so we don't have 2 5s in the numerator at all. Is there any other place we can reduce, though? Kate?
The 6 on the far left and the 3.
Okay, what does the 6 become? So there are 2 3s there, and now what do we have up here? Good job, -1. This is kind of messy, but people do like to evaluate this way because you don't have to keep rewriting, right? If we rewrote what's left, in the numerator we have 5 times -1, and in the denominator we have how many factors of 2? We have 2, 2, and 2, so we've got 3 factors, 2 times 2 times 2. We could even write that exponentially, right? Okay, so what is our simplified expression? Can you say it together? 3, 2, 1. -5 over 8. There it is. Okay, good job. So really we're doing exactly what we did yesterday after substituting values into expressions. Okay, so let's try it again. Pause the video and come back and check. We're going to work them out here. Okay, so here are the problems you can walk through if you're watching this by video, right? The answer here is -2 and 25/48. This should be a 25 here.
Yeah, I
And so what we're finding is that people are struggling with how to change an improper to a mix. So we're going to try that right here. -121 over 48. Fractions are division, right? So you go literally put the top number in the doghouse and divide by the divisor, 48. Top dog goes in the doghouse, right? And so 48, oh, this is a huge number, so you kind of have to make an estimate, right? And 48 is really close to 50. And so 50 times 2 is 100, so probably 48 times 2 is what's going to work here, right? 16,196. So you subtract. This is not hard. Now that is a negative number in there, but we kind of have to keep that aside and think about what that means for our quotient. But when we subtract 121 minus 96, we get 11 minus 9, which is 2. 25 is still being divided by 48. And because we had a negative divided by a positive, the quotient is negative. Think about it. If we multiply this negative times this positive, we'll get a negative. Okay? You've got to work out all those details. Okay, let's try just simplifying now. Can you simplify number 1? There is no way to evaluate it. I don't know what X and Y are, but you can simplify it. So please try, and then we'll talk about it. Okay, come on. So what's happening with number 1?
I think it's 2xy.
Okay, so anyone else have a thought? He said 2xy. Alex?
Yeah, x2.
X squared, right? And how did you get x squared?
Because I crossed out the y's.
Okay, because y over y equals what? 1. So we can say, some people like to use the term canceling, right? They're multiplicative inverses. They equal 1 when you have them stacked like that. So your simplified expression is x squared. Okay? If I knew fractions to insert here to evaluate, I might want to actually do this first. Why would I put in a bunch of numbers for y when they're going to be canceling out later, you know? Simplify your expression first. So in this one, this is really tricky, I think, for you people. Do you see a similar thing going on here? Do you see it? What is going on, Jake? Yeah, so it's y squared over y squared. So what will that equal? Y squared over y squared will equal just 1, right? So, but be careful. These two equal 1, so we do need to put a 1 in the numerator, right? Because that's what those equal. So your answer is really 1 over x. Okay? A mistake would be the answer is just x. It's in the denominator, right? You got to make sure that that's where it is in your answer. Okay, so we have to have a 1 in the numerator here because the x is actually in the denominator, right? On the left, question number 1 here. If I put a 1 out here, I mean, y over y equals 1, right? So what is x squared times 1? X squared. I don't even have to show that 1, do I? And I mean, I could show a 1 underneath it too, but do we show those 1s? We could show a 1 in front of it. It's a coefficient 1. We don't show those 1s. Those are, I call them the invisible ones, you know. You could put them everywhere all the time, so we don't do that. We try to keep things simplified. That's why. But if you do this sort of canceling here, you're going to have to show the 1 there because there's nothing left in the numerator. If there was something else, you wouldn't have to show a 1. But there's nothing, so you've got to show the 1. Okay? Go ahead and evaluate this expression. -7/16 plus 8 1/3 times 3/5. So this should like raise a couple of red flags. What is the first thing you think? Olivia Shane, what do you think?
I can cross out 3.
Well, wait a minute. What do you have to do first?
Oh, change the next number to a
Okay, so we can start there. -7/16 plus what?
plus 25 times.
Okay, and then what must a person do right now? And I think you were trying to do it.
Cancel
Well, so which operation must we do first?
multiplications.
Multiplication. Good. So this didn't say that, but this was testing whether you remember your order of operations, right? Just like on the Iowa test. It's not going to say, use your order of operations. It's just going to give you a problem with a couple of operations. And you need to remember that as a math student. I've got to do multiplication first. Okay? So Olivia says we can show that these are multiplicative inverses, which means there's a 1 in these places, right? We don't often show those because there's other stuff still there. So what about the 5 and 25, Olivia?
You can make it 5 over 1 times 1.
And 5, okay. Good. So let's simplify this and tell me what are we really adding here? What's left? It's just simply 5, and I guess you could say over 1. So now this is a bit tricky because a person would need to do what now, Kenzie?
You need to find the common denominator.
Good. And this is where you guys showed to be a little bit weak, finding that common denominator. And so what is the common denominator, Kenzie?
16.
So how will you get there? How do you change that?
You put 16 in the lower 16.
Okay, so you're going to multiply the top and bottom by 16. And so we end up with the correct denominator. And so what is 5 times 16, you know? It is, say it? 80. Good. Okay, once we get here, now you guys are pretty successful. When we have a common denominator, we simply do what's in the numerator. -7 plus 80 is up there, and it's all over 16, right? And we just have to do what's in the numerator. And what is -7 plus 80, Alex?
73.
So we have 73 over 16. Do we usually stop here, though?
No, we
We-
make 3
Mixed number. So did you do that already? What is it when you change
4
it?
and 9/16.
Do I have any other people agreeing with this? 4 and 9/16? 4 times 16 would be 40, 64. Yep, that's right, and 9/16. Good job. Okay, so multiple steps here. Bringing together everything from addition and multiplication all in one place. Okay? So you may take the assignment down and begin